Hello everyone and welcome you all in this revision class, and we are going to discuss whatsoever we have studied till now in this semester as well as whatsoever you have studied in the previous semester, because it is very crucial to understand these topics, as the fundamentals are always important and we should always look at the basics again and again. So we are going to first of all understand the objective of structural designing and process of designing, and then we would like to understand the difference between plain concrete and reinforced concrete, and then the basic properties of concrete like grade of concrete, characteristic strength of concrete, modulus of elasticity of concrete, pre-pen shrinkage, and durability. After understanding the basic properties of concrete, we will understand basic properties of steel and their types. So any house which we make is made up of two things. What are those? First one is the concrete and the second one is the steel reinforcing bar. Then whatever load we are going to apply on these materials, the stresses will be induced, and these induced stresses we have to analyze it by different methods, and the stresses can be different, and these induced stresses must not exceed the critical stress value mentioned in the IS code. And if the induced stresses exceeds the critical value mentioned in the IS code, then what will happen? Structure will collapse. According to Disaster Management of India, almost 2600 people die every year due to building collapses. For example, in 2013, 7-story building in Thane collapsed and almost 70 people died. And the reason of failure, it was because of the use of substandard construction material. कारण यह था कि कंस्ट्रक्शन मटेरियल्स की क्वालिटी बहुत ही कम थी. सो द फर्स्ट रिक्वायरमेंट, द वेरी फर्स्ट रिक्वायरमेंट ऑफ एनी स्ट्रक्चर इज द स्ट्रेंथ, and the condition is that stresses induced should not exceed the critical value. After ensuring the strength of the building, we also have to ensure the stability of the building against different factors, especially like overturning or buckling or sliding of the building. For example, in Kolkata, Ulta Danga, a 40-meter curve of a bridge, it just slided from its initial position, and it leads to the failure of the structure. So the stability deals with the three factors: overturning, buckling, and sliding. And the third requirement of any building is serviceability, and it is a condition under which a building or a structure is considered useful, and also to ensure the satisfactory performance of a structure under different types of load combinations. So serviceability deals with also different types of factors. For example, we can take like stiffness, deflection, impermeability, and durability of the structure. So all these factors are important to check the serviceability of the structure, whether the building is serviceable, रहने लायक है या नहीं है. For example, if we talk of Lotus Temple of Delhi, it's a very high class serviceable building, very durable in all the situations. Hence, in conclusion, the three important requirements of any structure is: the first one is the strength, second one is the stability, and the third one is the serviceability. In a strength, we check that induced stresses do not exceed the critical stresses. Stability deals with the overturning, sliding, and buckling, whereas serviceability deals with the stiffness, impermeability, durability, deflection, cracks, etc. Alright, so if you are going to build a house, first of all, what is the first phase? The first phase is the planning phase, which is carried out mostly by the architect planner to plan the layout of the structure. And the architecture meets the requirement of the client, like functional requirement, aesthetic requirements, budgetary requirement. This budgetary requirement is most important. And the second phase is the structural analysis and design. And this is being done by the engineer. And the engineer's job is to select the most appropriate structural design methods to bring the concept of architecture into reality. And then we estimate the loads on the structure, and then the structural analysis for estimation of those stresses. And after this, we do structural designing of actual proportion, for safety and serviceability. And this course basically deals with this system, structural design. We are going to learn the design of different elements of the beam. Alright. After structural analysis and design are done, we check it for the other normal conditions like safety and serviceability. If the requirement is satisfied, we go for the construction phase. And if the requirements are not satisfied, then certainly we have to revise the structural design procedures and we have to go back again to the second phase and then apply the methods, different methods wherever corrections are required, and that is done until we get a safe and serviceable design. In all the cases, we are going to deal with the two material only. First one is the concrete and the second one is the reinforced steel. And if we talk of concrete, there are two kinds of concrete: plain cement concrete and reinforced cement concrete. Plain concrete, as we know, is made of cement, aggregate can be coarse or fine, and water and admixtures. Concrete is generally prepared on the site itself. The concrete compressive strength is very high, as we have discussed, but on the other hand, the tensile strength is very negligent, almost negligent. So if we load a plain cement concrete, इसमें कोई reinforcement नहीं है, तो क्या होता है? Cracks become visible very easily, and that too of higher magnitude. It becomes very easy to break these concretes into pieces. To counteract this problem of cracking, we mix concrete with reinforced steel, and that becomes reinforced cement concrete, because steel bars are embedded in the concrete and they are named as RCC. So if you talk of steel is always manufactured in factories under controlled conditions, and this steel bar is going to easily take up the tensions that is going to be induced in the beams, and tension can be induced due to different types of stresses. It can be flexural tension, bending के कारण tension आ रहा, or it can be direct tension, or it can be diagonal tension, or even it can be environmental tension. So all these four kinds of tensions we are going to study in this course, and how do our member react to these forces. We design RCC members for the most critical value out of all these four kinds of tension, and then we check also for the remaining normal types of tension very easily. If we apply a very heavy load on RCC, then the hairline cracks are induced and they are not perceptible, and steel bars undergo yielding. Yielding is a property of ductility, and steel also imparts डक्टिलिटी टू द मटेरियल. डक्टाइल होने से क्या हो जाता है मटेरियल कि आपको ना फेलियर होने से पहले सफिशिएंट वार्निंग देता है, टाइम देता है डिफ्लेक्ट होकर के कि नाउ द स्ट्रक्चर कैन फेल, and when we receive such warning from the structure itself, and then we can easily take precautionary measures. Not only this, steel also improves the compressive strength of the member in comparison to the plain cement concrete. अगर हम प्लेन सीमेंट कंक्रीट से बनाते हैं मेंबर और एक आरसीसी से बनाते हैं, आरसीसी की स्ट्रेंथ ज़्यादा होगी. So I hope you must have well understood the differences between plain cement concrete and reinforced cement concrete. Now we will discuss design properties of concrete as well as the design properties of steel one by one. So let us start with the design properties of concrete, and different properties that are going to be used as characteristic compressive strength, very important, modulus of elasticity, creep and shrinkage, impermeability. Now the question may arise, how to represent the type of concrete on the basis of its quality, किस type of concrete है. So we demarcate a concrete by saying grade of concrete. मैं अक्सर क्वेश्चंस में दिया करूँगा grade of concrete, and grade of concrete is basically a measure of compressive strength, and compressive strength is measured by standard test on concrete cube. These concrete cubes are of dimension 150 mm into 150 mm into 150 mm. Cubes are tested under compressive strength. The grade of concrete is represented by, let us say, M20, in which the first letter M refers to the mix, and the numerical value 20 represents to the characteristic compressive strength. and this is measured after 20 days of curing, and its unit is megapascal or Newton per mm square. So in IS 456, in the table number 2, we can check there are different types of concrete which are related with the grade of concrete. When we talk of the type of concrete, we have to refer to the grade of concrete, and grade of concrete depends on the characteristic compressive strength of concrete. So what is this characteristic strength? This we have discussed in detail in another video, and it is represented by FCK. And the most interesting phenomena is that when we make different molds from the same concrete that we have casted in the same condition, and if we test them in the laboratory, and if we test them in the laboratory, we get different values of compressive strength, and the data is completely scattered on the graph. That's why we have discussed the characteristic strength curve and the definition why we choose only characteristic strength. And the definition says that we choose only that value of strength below which not more than the 5% of data is going to fall, and the variation is expressed in terms of either standard deviation or the coefficient of variation, and the coefficient of variation is equal to the standard deviation divided by the mean strength. All right, next property of concrete, that is elastic modulus of concrete. So concrete is a brittle material, it's not an elastic material. And if we look at the stress strain curve, we will see it's completely non-linear, and not only that, it's non-elastic, because when we do unloading, then it doesn't follow the same path. Only initial portion of the curve is linear, only initial. But the one thing is always true, that in the initial region the stress strain curve is linear, not exactly non-linear. From this formula we can see that elastic modulus EC depends on the strain, and strain is of two types: short term elastic strain and long term elastic strain. शॉर्ट टर्म इलास्टिक स्ट्रेन किससे हो जाता है? इंस्टेंटेनियसली लोड लगा और स्ट्रेन हो गया, बहुत ही जल्दी दिख गया. वेयर एज लॉन्ग टर्म इलास्टिक स्ट्रेन धीरे धीरे होता है समय के साथ, ड्यू टू द सस्टेन्ड लोडिंग. अगर हमने उस पर लोड लगाए रखा तो वो हमें स्ट्रेन दिखेगा. एंड सच स्ट्रेन आर क्रीप एंड श्रिंकेज. एंड कॉरेस्पॉन्डिंग टू शॉर्ट टर्म इलास्टिक स्ट्रेन वी हैव शॉर्ट टर्म मॉडुलस ऑफ इलास्टिसिटी कैपिटल EC, whereas corresponding to long term elastic strain we have effective modulus of elasticity of concrete, which is represented by capital ECE. There are different possible types of short term modulus of elasticity. First one is the initial tangent modulus, ITM. इसमें क्या करते हैं, हम एक tangent लेते हैं origin पे और उसका tan थीटा निकाल लेते हैं, वो tan थीटा को इक्वल कर देते हैं कैपिटल EC के. Second one can be tangent modulus. This is not initial tangent modulus. Tangent modulus क्या होता है, आपने कहीं पे भी से पॉइंट XY पे आपने tangent लिया और फिर उस tangent की tan थीटा आपने पता की और वो उस पॉइंट की शॉर्ट टर्म मॉडुलस ऑफ इलास्टिसिटी होगी. Whereas we can have secant modulus of elasticity also, and this is the slope of the line joining the point XY and the origin. So all these three values of modulus of elasticity comes under the category of short term modulus of elasticity, and this we can very easily calculate if we have the equation of the curve or the graph of stress strain curve is provided. The IS 456 provides us the empirical formula for short term modulus of elasticity, and it says capital EC is equal to 5000 into root under FCK, and this value is derived based on initial tangent modulus. Let us try to understand the tensile strength of concrete. Tensile strength is 7 to 15% of the compressive strength. अगर compressive strength 100 मेगापास्कल है तो टेंसाइल स्ट्रेंथ कितनी होगी, 7 मेगापास्कल या 15 मेगापास्कल. And it is calculated by tensile strength tests. They are of three types: direct tension test, splitting test and flexural tension test. देखिए डायरेक्ट टेंशन टेस्ट हम जनरली क्या करते हैं, उसमें कंक्रीट ब्लॉक को डायरेक्टली टेंशन अप्लाई करते हैं दोनों तरफ से. पर क्या होता है, इस केस में जो ग्रिपिंग हम बनाते हैं ना, इस तरीके से दोनों तरफ से पकड़ते हैं कंक्रीट के सिलेंड्रिकल स्पेसिमेन को, और उसे जब डायरेक्टली टेंशन अप्लाई करते हैं तो ग्रिपिंग के कारण सेकेंडरी स्ट्रेसेस इंड्यूस हो जाता है, और जो टेस्ट रिजल्ट आता है वो इट डजंट गिव अस द एग्जैक्ट रिजल्ट्स. So instead of using direct tension test results, we do splitting test. In this test, we take a cylindrical specimen of concrete and we apply compressive strength along the diameter of the specimen throughout its axis. And the result which we get is much more reliable, and that is called splitting test. But often we go for flexural tension test. In this, we take a specimen of 100 mm into 100 mm into 500 mm, and here we apply loading using 3-point method. जैसा कि नाम ही सजेस्ट करता है, 3-point method क्या है, इसमें 3 पॉइंट से लोड एक्ट कर रहा होगा स्पेसिमेन पे. 2 तो सपोर्टिंग पिन हो गए और एक ऊपर से लोडिंग पिन. और जब हम लोड लगा रहे होते हैं इस तरीके से फ्लेक्सुरल टेंशन टेस्ट में, तो क्या होता है, द मॉडुलस ऑफ रप्चर हम कैलकुलेट करते हैं. मॉडुलस ऑफ रप्चर इज रिप्रेजेंटेड बाय FCR, and this is equal to the theoretical maximum tensile stress that develops at the extreme fiber. And from the famous formula of Euler's-Bernoulli equation or the bending equation, we know that FCR is equal to m by z. So this formula can also be used, but we know in case of concrete, since it is a brittle material, the elastic modulus is not constant. Elastic modulus is varying. आपने देखा था ना फॉर्मूला, EC is equal to 5000 root under FCK. Instead, IS 456 provides us an empirical formula which says FCR is equal to 0.7 into root under FCK. ठीक है, तो आप इसे याद रख सकते हैं. And the most interesting thing which you can observe in this formula is that the FCR, which is the tensile stress, and FCK is the compressive stress. So this is a relationship between the tensile and compressive stress of concrete. कितनी अच्छी बात है ना, एक ही फार्मूला में दोनों ही स्ट्रेस को आप रिलेट कर सकते. So just now we have been discussing the modulus of elasticity of concrete, and we have discussed the short term modulus of elasticity, and then comes the long term modulus of elasticity, which depends on creep and shrinkage. So let us first of all understand the creep. Creep is represented by theta, and creep is defined as the strain which is time dependent component of total strain. देखिए, जो total strain होगी उसके 2 पार्ट होंगे. एक तो होगा instantaneous strain, कि आपने जितना लोड लगाया उसकी correspondingly strain डेवलप हो गई. Whereas अगर आपने उस लोड को सस्टेन किया, कंटिन्यू किया, then what will happen? क्रीप स्ट्रेन विल डेवलप. स्ट्रेन आपने लोड बढ़ाया नहीं, पर फिर भी स्ट्रेन बढ़ता जा रहा है, डिफॉर्मेशन बढ़ता ही जा रहा है, एंड दैट डिफॉर्मेशन इज ड्यू टू द क्रीप स्ट्रेन. सो ऑफ कोर्स बोथ ऑफ दीज स्ट्रेन डिपेंड्स ऑन द स्ट्रेस वैल्यू, एंड द क्रीप कोफिशिएंट थीटा इज डिफाइंड एज द रेशियो ऑफ क्रीप स्ट्रेन एट एनी टाइम t divided by the instantaneous strain that has developed in that member. And also you can look at this graph of total strain versus time t, and here total strain refers to both instantaneous strain plus creep strain, and creep strain is increasing with time, and at time say t is equal to infinity, it reaches a saturation level, and the curve finally reaches a ultimate creep strain value. So one question that may arise is that what will happen to creep strain if we remove the sustained loading. जो loading continue act कर रही है उसे हमने हटा दिया तो क्या हो जाएगा, the unloading will happen. और unloading का ग्राफ भी ना सिमिलर ही होगा creep के ग्राफ की तरह, in which some part will be instantaneous recovery. जितना लोड हटाया उसके correspondingly instantaneous recovery मिल गई, but with time also there will be some creep recovery, कि अब तो लोड लग नहीं रहा तो धीरे धीरे वो ओरिजिनल पोजीशन पे आता जाएगा, बट नॉट फुली. देयर विल ऑलवेज रिमेन सम रेजिडुअल क्रीप स्ट्रेन लेफ्ट इन द मेंबर. सो नाउ कम्स द लॉन्ग टर्म मॉडुलस ऑफ इलास्टिसिटी ऑफ कंक्रीट. अब आप अच्छे से समझ पाएंगे क्या होता है लॉन्ग टर्म मॉडुलस ऑफ इलास्टिसिटी ऑफ कंक्रीट, एंड दिस इज रिप्रेजेंटेड बाय capital ECE, which is also said as effective modulus of elasticity. And effective modulus of elasticity is equal to short-term modulus of elasticity EC divided by 1 plus theta. Theta is the creep coefficient. Now the second parameter is shrinkage. From the hardened state, when the water vapor evaporates due to the loss of moisture, concrete shrinks. Now shrinkage are of two types: dry shrinkage and differential shrinkage. So dry shrinkage is, as the name suggests, reduction in volume of concrete due to evaporation. And in dry shrinkage, one thing is common with the creep and one thing is not common with the creep. What is common with the creep? कि induced time dependent strain, कि समय के साथ साथ strain इसमें भी बढ़ता जाता है. But the thing that is not common with the creep, that this doesn't depend on the external loading, independent of the stress level. बाहर से आप लोड हटा दें या फिर लोड कंटिन्यू करें या बढ़ाएं, the strain will go on increase. Unload नहीं कर सकते shrinkage strain को, ठीक है. And when in case if shrinkage is restrained, allow नहीं किया आपने, shrinkage होने नहीं दिया, then it will develop tensile stresses and it leads to cracking. Next type of shrinkage is differential shrinkage. This type of shrinkage mostly develops due to the thermal gradient or due to unsymmetrically placing the reinforced steel bars in the beam. Just like you see your own body, if we bisect the body, it has symmetrical structure. So in the similar way, we provide a steel in the structure unsymmetrically. The structure will not be in the normal condition. This will leads to the development of differential shrinkage. The last property of concrete is durability. What is durability of concrete? Durability is the property of concrete to serve the purpose for which it is designed during its intended lifetime. And durability also depends on various factors, out of which there can be some internal factors and there can be some external factors. If you talk of internal factors, क्या हो सकते हैं कि हमने किस तरीके का मटेरियल उसमें यूज किया है, like alkali reactive aggregate or salty water. And the external factor mostly depend on the environmental effects. So what are the effective ways to increase durability of the concrete? And the first one is the most practiced is to provide the clear cover. Just like you can see in this picture, this is the cross section of a beam and the distance between the extreme fiber to the center of the reinforcement bar is said to be the nominal or clear cover. CC से भी रिप्रेजेंट करते हैं, ठीक है. सो दिस क्लियर कवर प्रोटेक्ट्स द मेंबर फ्रॉम द एक्सटर्नल फैक्टर्स. तो ये तो क्लियर कवर की बात हुई. और अगर स्टील की बात करें तो वी कैन ऑल्सो यूज कोटेड स्टील, दैट इज बेटर फॉर इंक्रीजिंग ड्यूरेबिलिटी. एंड इफ वी टॉक ऑफ कॉन्क्रीट, सो वी शुड यूज appropriate minimum grade of concrete according to the environmental exposure condition. देखिए ये IS कोड में डिटेल से दिया हुआ है किस तरीके का कंडीशन है, ठीक है. तो यू कैन सी इन द कोड, दिस टेबल इज एक्सप्लेन्ड देयर विच काइंड ऑफ एक्सपोजर कैटेगरी इज देयर, एंड यू कैन सी माइल्ड, मॉडरेट, सीवियर, वेरी सीवियर एंड एक्सट्रीम. And in the next column you can see the description corresponding to different exposure category. So for example, if you take a structure constructed near a coastal region, then we know that structure is exposed with the sea water and the corrosive fumes or severe freezing. We go for the very severe exposure category. And minimum grade of the concrete is M35. Minimum clear cover is 50 mm. So this was all about the different properties of concrete. We have discussed the characteristic compressive strength, modulus of elasticity, also tensile strength, creep, shrinkage and durability. So these are the 5 most important characteristics of concrete. So I just brought these points here in our lecture series just to make things very clear, because we are going to use all these things as we go forward in this course. So now, after understanding the properties of concrete, we come to the properties of reinforced steel. Many a time you will see the term rebars in the textbooks or the problems. This rebars is the short form of reinforcing bars. If you talk of the size of bars available in the market, the nominal diameter is available from 5 mm to 50 mm. But basically we will be using bars ranging from 8 mm to 32 mm. Bars are of two types: plain bars and deformed bars, and you can clearly look at the difference in the surface of both the bars. In the plain bar the surface is very smooth, whereas in the deformed bars there are lugs provided on the surface. Why these lugs are provided? This is very simple. क्यों होगा? To enhance the bond between the steel and concrete. So just like in the concrete we have grade of concrete, so we will also be having grade of a steel, and grade of a steel is the yield strength of a steel. What is this yield strength? As we have discussed in the graph also very detailed, as per the code it says that specified yield strength may be treated as the characteristic strength Fy, and this is also expressed in Newton per mm square. So there are different types of steel. The first one is the mild steel. It is represented by Fe250, and this is less used because of their low strength. I would not say that this is not used, because we use it for providing as a distribution bars or stirrup bars, but not as the prime main bars which provides the strength to the members. So mild steel is less commonly used. And if you look at the stress strain curve of mild steel, the graph follows this pattern. And then comes the medium tensile steel, and this is also not much used. And the third one is the cold twisted bar, and this is also known as H/SD, high yield strength deformed bars, and it is represented by Fe415 or Fe500. And in the TMT bars we have two layers, the inner core and the outer core. Inner core is basically soft and ductile, whereas the outer cell is having very high strength, as well as anti-corrosive coating is also provided. So this is additional benefit of TMT bars. So if you talk about modulus of elasticity of steel, capital ES, for all the grades of steel, the graph is linear till the point of their proportional limit, and the slope is constant in case of steel, because steel is an elastic material. And as per the IS code, modulus of elasticity of steel is a constant, and this value is equal to 2 into 10 to the power 5 megapascal. So let us first of all take the case of mild steel bars. So if you look at the stress strain curve of mild steel, you will find that the yield point of mild steel can be very easily determined. How? Because after the yield point there is a plateau, and we can easily obtain that value, whereas for the high yield strength deformed bars the graph is not uniform like that. So in that case we have to adopt some different methods. So in this case we have to take the yield stress corresponding to the value of 0.2% proof strain. Saying 0.2% proof strain means what? Proof strain is equal to 0.002, and at a strain value of 0.002, if we draw a line parallel to the elastic curve of the steel, and the point where it intersects, that value of stress is considered as the yield stress of the H/SD bars, and the strain value corresponding to the yield stress of H/SD bar is equal to 0.002 plus Fy by capital ES, because the slope is same for both the lines. And how does this value of a strain comes? We have explained it to you elaborately. So I hope this must be very clear to you. So after understanding and going through all these fundamentals, you will find what we are going to discuss in the coming classes very interesting. So with this we would like to end off here. Stay tuned and stay safe. Thank you.